look at a composition and a decomposition problem. We're going to start with the composition problem. It says complete and balance the following chemical equation. Make sure you show the physical states. So we're going to start with lead. All right. And lead, just Pb. And it's going to be a solid. Notice no charges, not an ion or anything. And with bromine, remember bromine's diatomic. So Br2. And we look at the periodic table and find that bromine is a liquid. So we have lead plus bromine yields. And since you have two elements on that side, the only thing this could lead to, if it's going to, reaction is going to occur, is going to be a composition. We also call this synthesis. And these two will combine. Now, the problem here tells you that lead will end up in a +2 oxidation state. So we will end up with lead, and that will be a +2. So remember, when bromine goes to be an ion, we're going to have a lead 2+, and the bromine is going to have a negative charge. So we need two bromines, Br2. And this is going to be an ionic compound, so we can write it as a solid. Now when we do this, let's go ahead and see if things are balanced. On this side we have lead, on this side we have bromine, on this side we have lead, on this side we have bromine. So looking at the problem now, one lead, two bromine, two bromine. This is in fact balanced. So this equation that we already have written right here at the top is the balanced equation, also showing the physical states. Now let's move on to the next one, zinc hydroxide. Now zinc is one of the ones on the stair step that we talk about. Zinc has a 2+ charge on it. And hydroxide, polyatomic ion, has the -1. And it's going to be heated. So let's go ahead and start writing this out. Zinc hydroxide, ZnOH, you're going to need two hydroxides. And this is in fact zinc hydroxide, ionic compound. It's a solid. When heated, how do we show heat? We put the delta sign over the arrow. So that's going to be heated. You have to include that. Yields. Now we start out with a compound, really not a lot to combine with. And since we're adding the heat, this will be a decomposition reaction. You should be able to recognize that. And what it's going to be left with then, when you have a metallic oxide, hydroxide, I'm sorry, when you have a metallic hydroxide, zinc's a metal, it's combined with a hydroxide, this will result in an oxide formed with the metal. So ZnO. Remember, once again, zinc is going to be a 2+, oxygen, it's going to be an oxide. There's going to be a 2-, so it's going to be a 1-to-1. And it will be, once again, ionic. So solid plus, and when we have metallic hydroxide, it also forms water. And the water, we added the heat, is going to be in the form of a gas. It goes away. So that is my skeleton equation. So now what I need to do is write down what I have, and a lot of times it helps to write water as HOH, but in this case I only have my hydroxides as my source of oxygens and hydrogens. So I'm going to write zinc, oxygen, hydrogen on that side. I'm going to write zinc, oxygen, and hydrogen on this side, and now I'm going to balance the equation. On this side I have one zinc, I have two oxygens, and I have two hydrogens. On this side, I have one zinc. If I look, I have a total of one oxygen from the zinc oxide, one oxygen from the water, two oxygens, and two hydrogens from the water. This is, in fact, balanced once again. So remember, metallic hydroxides form oxides combined with a metal, and water And then we go to balance this equation. This one ends up being balanced already, giving us our final answer.